recommend you study, but I'll try to make it so you can't. By which I mean, in my philosophy, if you did your assignments and you kept your eyes open and paid attention, you should do just fine. I will try to focus on your assignments, by which I mean asking questions that try to discern, did you understand what the heck you were doing? If somehow you pulled off your assignments without understanding what you were doing, you have some studying to do. Go figure out what you did. If you understood what you did, I hope you'll do well on the test. And that's my intentions. Okay? I relate to that philosophy, but I'm still fighting it. Yeah. Okay, if there are equations, so I think a bad example of a test question would be, what is the equation for, what is Bellman's equation? Why is that a stupid question? Because the first thing you do in the real world is you open up your web browser and say, Bellman equation. And there it would be, right there on Wikipedia, dumb question. Of course, it might take you a while to find it. Is that it? I think that's it. Okay. A good example would be, here is the Bellman equation, blah. What does this term do? Or what would happen if why does the Bellman equation have 2 values inside of this function? Or something like that. I think that's the kind of thing that is valuable. I do feel it would be fair game if I were to show you a version of an equation that you had never seen before, like it had changed variable names, and you had to be able to adapt to that. Why is that a good thing to do? Because that really happens. You'll be taught on this equation, and then in the wild you'll encounter that equation, and somehow you have to figure out what has the same meaning and operate with it. Looking back, I don't think I actually did that yet. So unless I go and change my test, it'll be the equations you're familiar with. But
this one uses beta instead of gamma.
Yeah, this one uses beta instead of gamma. Excellent example. I could just show you that, say this is Bellman's equation, and you'd have to deal with the fact that this is a beta instead of a gamma.
The B stands for Bellman.
Is it B for Bellman? Okay, probably. It should be D for discount factor, delta for discount factor or something. I don't know. V for value. Yeah, I do want you to focus on equations. So think about all the equations we've ever gone over and make sure you get why we use them, what the terms do, that kind of a thing. Because that's going to be a bulk of what's on there. And I really want you to get algorithms, like any algorithms we studied. So let's list what we've studied. We have done reinforcement learning. We have done KNN learner, and we have done unsupervised learning. Well, I guess let's say we did a supervised learner. There, we did 3 types of learning. In reinforcement learning, we studied a Q learner, and in particular a deep Q learner, which used a neural network to represent the Q table. For supervised learning, we studied KNN and didn't study much else, although we kind of touched on neural networks. And for unsupervised learning, we did PCA and ISOMAP and MVU and multi-dimensional scaling.
We cover the incremental application.
Do we talk about incremental applications? Oh, backpropagation. I never taught how to do backpropagation. You should be aware that neural networks use backpropagation. Backpropagation is how we update the weights, and the way it works is by gradient descent, meaning we differentiate the neural network with respect to its weights and step in the opposite direction of the gradient. If that all made sense to you, you get as much as I feel I have taught about backpropagation. Okay? If you get all these things well, I think you'll do well. What I plan to do is just kind of pick at questions about these algorithms. For example, what makes Q-learning guarantee to find the optimal policy? Do you know why Q-learning finds the optimal policy?
Conversion.
Basically, because we iterate for all of eternity until it's optimal, right? But you should get why and how. K and N, can it represent any function? If you have a big enough training data,
Why not?
sure, yeah. I mean, you just sample the heck out of the thing until it can represent any function. So there you go. Make sure you understand why the algorithms work and what would make them not work. A KD tree. Why does it guarantee to find the k nearest points?
Because it checks everything that could be closer first.
Yeah, because it systematically does it until it couldn't be wrong. And what if I made this change to a KD tree? Would it still work? What about that change? Those types of questions, okay? Let's see. I remember there were other questions people asked, but I can't remember them now. So can anyone ask any more questions?
Related to this topic.
Yeah, what would you like me to talk about? How can I help you do well on this test?
Oh, sorry.
You go ahead.
He had his hand first.
Major data on the test, like how many items, how many questions, and stuff like that.
Oh, yeah, there's mostly multiple choice questions. And there's going to be about 15 to 18 questions. I think I've written 14 so far, and I plan to go add a couple more. So there will be more than 14 questions and less than 20 questions. Mostly multiple choice, but a few of them are short answer. So, and when I say short answer, I don't mean spew everything you know. I mean limit yourself to like 20 words, short answer. And I think there's one where I actually ask you to draw a diagram. So you can sit around and think about, what do I know that we could draw a diagram of? And it's not going to be a big one. It'll be a small one with like 2 boxes on it. But there you go. Okay. I like multiple choice because it's easy to grade. I hate multiple choice because it causes too much variance in the scores. But what else can I do? Usually I give you a few points for writing your name on the test, and that slightly reduces the variance. And I don't know. Yeah, multiple choice creates a lot of variance because a lot of people guess, I guess. That was an ironic statement. Yep. Okay. Any other questions? What have we gone over this half semester that you're uncomfortable with that I could just talk about for a little bit? Yeah. So I guess I need to understand what you mean by adjustment.
So when we're scaling,
Here's isomat.
so when we're doing yes.
Okay, so we're doing multidimensional scaling. Is the question, how do we move the points such that they have the correct distance from each other?
Yes.
Okay.
So essentially, I guess what I'm asking is how do you do that perfectly? So I've kind of played back and forth with doing a random dimension every time.
Ah,
But
okay. So yeah, this does sort of require a little bit of linear algebra comfortableness. And that's certainly something I haven't taught. If you have a vector, suppose your vector is 2, 4, and you want to add another vector, 1, 1, that yields the vector 3, 5. This is the addition of 2 vectors, right? I think we're all comfortable with that. But suppose we're in this space. Now we have to do vector math instead of scalar math. Usually it's just apply it to every dimension and then you've done it. At least that's the case with addition and multiplication. So the question is, how exactly do we adjust the points here? I think it's best to think about doing it on the whole vector, not doing it on per dimension, but you do end up doing it per dimension. Okay, that didn't come out very well. But so let's start by computing the center point. A plus B divided by 2. Well, if A and B are 2, 4, and 1, 1, then we add them up and we get this. Then we divide it by 2, and we get 1.5, 2.5. So this is the centroid. Let's suppose this one is A, and this one is B. Okay, so there's the centroid, sum is that. And now we need to know distance. Let's see. We need to know C divided by 2 and D divided by 2. So what is C? Distance between A and B is going to be square root of 2 minus 1 squared is 1, plus 4 minus 1 squared is 9, which equals square root of 10, right? Okay, and D is going to be given to us. So if they're square root of 10 apart and we want them to be 5 apart, then we could do that. C divided by 2 is square root of 10 divided by 2. D divided by 2 would be 2.5. Now we need to adjust those points. So we'll say B prime is going to be what? B minus, oh wait, what is it? We're going to take B minus centroid. We know how to do that. That's just vector math, right? Then we're going to divide that by C over 2 and multiply it by D over 2. Okay, so that first one is a subtraction. We just do it element-wise. The division, we're going to divide that one number by, or divide every element by that one number, and then multiply every element by that one number. Oh, and then when we're done, we have to add in the centroid again, right? So we've taken the difference between B and that centroid, divided out the old distance, multiplied in the new distance, add it back to the centroid, and now we have the new B prime. So yeah, there's a bunch of operations that have to be done on an element-wise basis, but that will result in a new vector. Is all of that clear? And did that answer the question, or did I totally miss it?
Absolutely.
Yeah, I think I'm saying D is C is the current distance and D is the target distance between A and B. Yeah. When I say minimally, I'm going to say this is minimally because they're moving on the same line. If they moved off of that line, it would be superfluous motion. And equally, I mean, A should move the same amount as B. So basically, this computes the minimal and equal adjustment for A and B.
So in one iteration, you push it to the target distance right away?
Yep. I did state that it's actually probably better to only go some portion of the distance.
Yeah.
If you only go 10% of the distance, or maybe 50% of the distance, then it'll take several iterations to get there, but I think that will help avoid local optima. I haven't done enough testing to know how important that is, so I'm leaving that superfluous for you. I think if you just go all the way, it should just work. Anyone want to validate that?
Yeah.
I think I got a nodding head. Okay. So yeah, just go all the way. Although I think it'll be better if you go part way. Yeah, okay. Should I talk about reinforcement learning since it's been a while?
Oh, you got 1 minute.
1 minute. Yeah, I can't get a lot in there. Let me put it this way. If you guys have other questions, I would like to answer them, so please post questions on the forum, and then I can answer on the forum. I might just send you a link to my lectures if I feel I've already discussed it, or maybe I'll say that's in the lectures, you go find it, I don't know. But let's see, I would be happy to field specific questions. And plus, if I answer to the forum, I don't feel that I'm giving unfair bias to anybody else because we're all receiving answers from the same forum. Okay, and plus we can also help answer each other's questions if I happen to be asleep. So I guess I'll leave it at that for now. See you Monday, and let me know if you have any questions.